Hello, my geometry students. All right, so in this unit, we are doing a little bit of a review for solving systems of equations. And the reason we're doing this algebra review in this particular unit for geometry is because we are graphing and writing equations for parallel and perpendicular lines. So we're kind of applying our algebra knowledge to this idea of graphing parallel lines and graphing perpendicular lines, and then perhaps using a system of equations to solve for where they might intersect. Okay, and we're also going to see systems of equations come out of some of our representations of parallel lines being cut by a transversal. So it's possible that you might have more than one variable as we're looking at these angle relationships of parallel lines being cut by a transversal. So that's another time that you might be using it. So we're going to start with substitution. So there are a couple different ways to start when you're, when you're graphing or solving a system, you can solve by graphing. Okay, so that's one way you can solve a system. Another way is with substitution. Another is with a process called elimination. So we'll take a look at one of each of those. And then we're also going to take a look at a story problem before we finish the video. Okay, so one of the things that you can do is kind of look at the two equations that you've been given. And if we're solving by substitution, it's nice to have one of the equations either says, say, y equals information or x equals information, so that we can take that information that y is equal to or that x is equal to and actually plug it into the other equation. So I'm going to go ahead and take this bottom equation right here, and I'm going to solve it for y. 6x plus y is equal to 16. And if I subtract my 6x from both sides, I end up with y is equal to a negative 6x plus 16. Okay, so that becomes my substitution, right? That becomes what y is equal to, that whole expression right there. So the next step for substitution would be to grab your second equation right here, and we'll change it up and make it green here. So grab your second equation, and in the place of y, I'm going to leave a spot to substitute all of this stuff we know that is equal to y. So here it is, the minus 6x plus 16. We're going to drop that minus 6x plus 16 right into that spot. And that is your substitution. And then we can just simplify from there. So you want to watch your negatives. We have negative 8x. And a negative 5 times a negative 6 is going to be a plus 30x. Woo! What's negative 5 times 16? 80? I think that's right. Minus 80 is equal to 8. So we're going to kind of keep simplifying this. It looks like we're going to have 22 and 88 after we add 80 to both sides. So let's add 80. We're going to sneak right over here. We're going to combine like terms between the negative 8x and the 30. So we get 22x is equal to 88. And after you divide by 22, then we get x is equal to 4. And that's awesome. But don't forget, you have to plug it back in, right? So don't forget that process of plugging things back in. So in order to solve for y, it's going to be a negative 6 times my x value of 4 plus 16. So what does that turn out to be, guys? Negative 24 plus 16. It's going to be negative something. Negative 8. Hopefully you guys were thinking that. Looks about right. Okay, so once you have your value of x and your value of y, then you are finished when you're solving a system. Nicely done. All right, let's try this next little piece. This next little piece is going to be an elimination problem. And the idea with elimination is to actually eliminate a variable. And you guys might remember this, hopefully, from your work last year. And what I like to do is I like to look for some number I could multiply through by here to create opposite terms. You don't have to go this route of opposite terms, but I like to use it so when we can just add everything in our columns. So I'm gonna go ahead and recognize that if I multiplied this side by 2 and I multiplied this side by 2, that's going to create a little negative 2y right there, which is going to be opposite my positive 2y. So we'll see if we can't kind of section off some of my video here for this process. So we're going to have a negative 8x plus 2y equals a negative 20. That's just my original first equation. I've just rewritten it over here so I can line up my values. And if we multiply everything through by a 2, 2 times 16 is going to be 32x. 2 times negative 1 is going to be a minus 2y. And 2 times 22 is going to be 44. And then the process with elimination is you're just going to add going down your columns. Okay. So negative 8 and a positive 32 should be, what's that going to be? 24? What do you guys think? Okay. 24x, be thinking along with me here now. And a positive 2y and a negative 2y, that cancels. That's what we wanted to have happen. That is awesome that that happened. And over here, my negative 20 combined with my positive 44, it's going to be 24. And now my last step is to divide, and I get x is equal to 1. Now, am I finished? Okay. You should be shouting out, no, I'm not finished. I still have to solve for y. All right, well, let's grab the first one. It doesn't matter which equation you plug it back into. I'm going to go ahead and grab this first equation. The negative 8x plus 2y is equal to a negative 20. And in the place of my x, I'm going to get rid of that x because I know what x is equal to. And I'm going to plug in my x is equal to 1. So it looks like we have negative 8 plus 2y is equal to a negative 20. We're going to add 8 to both sides. We're going to do a little mental math here to save space. Add 8, get negative 12, and divide by 2, and we get a negative 6. So now you have a value for x and a value for y, and you are finished. Okay. Hoping those examples kind of restart your brain on solving systems of equations. And let's tackle one more here, which is a story problem, before we call it a day. So I'm going to scroll this up a little ways here, and we'll read this one together. All right, guys. Rob and Natalie each improved their yards by planting daylilies and ivy. They bought their supplies from the same store. Rob spent $65 on 3 daylilies and 14 pots of ivy. I think we need to define some variables here. Let's, oftentimes in story problems, you have to define what is going to represent your variable x and what is going to represent your variable y. Let's make x be the number of, and it's not going to be the number of, do we know the cost? Maybe we should make it be the cost. I bet that's what we have to figure out. Let's make x be the money for daylilies. Okay. And let's make y be, what else do we have? Pots of ivy. So let's make y be the amount spent for pots of ivy. Okay, so this is actually going to be a super important first step for all of your story problems, is just to define what your variables are going to represent. And you could have used D for daylilies and I for ivy. I'm just going to keep it in terms of X and Y, so that's a little easier. Okay, so here we go. $65 total. Wow, that's a lot of money on 3 daylilies, which we know cost X dollars, and 14 pots of ivy, which we know cost Y dollars. Natalie spent $34 on 6 daylilies that we know cost X dollars, and 4 pots of ivy that we know cost Y dollars. Now, you can solve a system like this with substitution. I'm looking at this 3 and this 6 and thinking, oh, if I multiplied this top equation through by a -2, I could get some elimination of terms here and possibly solve for Y, and then use that information to go back and solve for X. So I'm going to lead us down this path of making a choice. And it doesn't have to be this choice. This is just the choice that I'm sharing with you that I would make, of multiplying this side of the equation by -2 and this side of the equation by -2. And again, I picked -2 because I want to make this term right here into a -6x, opposite this term right here. Okay, so we're going to have a new system, and I'll go ahead and we'll write our new system. The whole thing, we'll write it in blue. So -2 times 65, what's that going to be? -130? Is that right? Because 60 is 120, extra 10 on there. And then we're going to get a -6x when we multiply a -2 here. And then we're going to get minus 28y when we multiply our -2 here. And then I'm just going to go ahead and grab this second equation, and I'm going to write it right underneath my original equation. My x is lined up, my constant's lined up, my plus 4y over here, and we'll just keep going. All right, so as we add going down, it looks like we're going to get a negative, what's that going to be, 96 is equal to, and then these are going to cancel. Perfect, we wanted that to happen. -24y, and as you divide by a -24, I think that's going to be 4. You guys can double check my mental math on that if you would like, but it looks like 4, a positive 4, would be equal to y. So that means that over here, our pots of ivy are probably going to cost $4 a piece, right? So now we know what y is equal to. Now we got to go back and find x. I'm going to grab this smaller equation with the smaller numbers. You don't have to. You can grab, your original equation, or even the equation that you multiplied by through by -2 on both sides. I'm gonna grab this one. So I know that Natalie spent $34, and there were those 6 daylilies that we still don't know the cost of. There were those 4 pots of ivy that I know cost $4 each. So I'm going to use that information to keep solving and keep working here, and subtract 16 from both sides. And what's that going to leave us with? So that's going to leave us with 18, right? So 18 is equal to 6x. And as a last step, we're going to divide by 6. And we get 3. All right, guys, we did it. So that means that the daylilies must be $3 a piece. So see how you can use your knowledge of x and use your knowledge of y, and the fact that you've already defined your variables right over here to actually know what your numbers mean, so that you can actually answer the question being posed. All right, keep that in mind as we move forward with story problems and systems of equations. Well done, guys.